Welcome to Solutions to the Regents Physics Waves and Sound problem set, problems numbers 1 through 3. Let's start with number 1. Suppose you hold a 1 meter metal bar in your hand and hit its end with a hammer, first in a direction parallel to its length, and second in a direction at right angles to its length. Describe the waves you produced in the two cases. Okay, well, in case 1, here we have our metal bar, and here we have our hammer, which we're going to strike at a direction parallel to its length. And to begin the discussion, we have to remember that the metal is made up of a whole bunch of atoms and molecules. And when we go ahead and strike the metal bar in a direction parallel to its length, we'd be hitting it this direction as shown. We would cause the atoms that make up the metal bar to vibrate in a direction that is parallel to the length. In the meantime, the energy from the hammer striking the end of the metal bar would also travel parallel to the length as well. And this would create a longitudinal wave in the bar. The energy is traveling parallel to the length, and the molecules are vibrating parallel to the direction of the energy movement. That is a longitudinal wave. In our second case, we're going to take the hammer and we're going to strike the metal bar perpendicular to its length. So we're going to hit it on the end here like this. And again, here are molecules making up, or atoms making up the metal bar, and these atoms are going to vibrate back and forth in this direction, the same direction that the hammer is striking the bar, but in this case the energy travels in this direction as just like in the previous example. So the energy from the hammer strike is going to travel this direction, while the molecules, due to the hammer strike, are going to be vibrating in this direction. This, of course, will create what is called a transverse wave. And so there you have it, the description of the waves you produce in the two cases. For number 2, suppose you repeatedly dip your fingers into a sink full of water to produce circular waves. What happens to the wavelength as you move your finger faster? This is an analysis of the wave equation. And the wave equation, as you learned, is V equals F lambda. It's the equation that relates the speed of the waves, the frequency of the waves, and the wavelength of the waves in the medium in which the waves are moving. One really important concept here, and this will be emphasized over and over again, especially when we study refraction, is that waves don't change speed unless they change medium. In this particular case, the water is not changing depth, which constitutes a change in medium for water. So because the water is all the same depth, the speed of the waves remains constant no matter what you do. Well, as described here, you're moving your finger faster. So what does that impact? That impacts the frequency of the waves. So the frequency of the waves is increasing. You're producing them at a more frequent rate. I think that makes intuitive sense. Well, look at this mathematically. If the speed is to remain constant, and the speed is a product of the frequency and the wavelength, then how must the wavelength respond with an increase in frequency? And of course, we get that the wavelength must decrease proportionally by how much the frequency increases. So, for example, if the frequency of the waves being produced were to double, the wavelength would have to halve in order to cancel out and have the product of the frequency and the wavelength remain constant. Lastly, number 3, what happens to the period of the wave as the frequency increases? Well, here we have the familiar period formula that you learned back in simple harmonic motion that relates period and frequency. Period equals 1 over f. Well, you see here and are reminded that period and frequency have an inverse relationship. So if the frequency increases, what must happen to the period? It must decrease. So the period of the wave would decrease as the frequency increases. All right, that'll do it on our analysis of problems 1 through 3. More to come as we do problems 4 and 5 in class together tomorrow.